Hi everyone. The rest of the first introductory lesson is going to happen now. So we're going to use the distributive property in reverse in order to simplify the expression of 2x plus 4. So let's look at that. You're looking for a common factor to both terms, right? So we've got 2x plus 4 is equal to 2 times the quantity of x plus 2. Now, how did you get that, Miss Velasco? Well, look at the distributive property. 2 times the quantity of x plus 2 times the quantity of 2. I'm sorry, that's a little tight in there, but I hope you can see it. And what is 2? What is 2 times x? It's 2x. And what is 2 times 2? It's 4. Okay, so that's our check. 2 is a common factor for this. So you can rewrite this expression, 2x plus 4, this way. 2 times the quantity of x plus 2. So that is the reverse of the distributive property. If that helps, see you in a minute. Okay, we're going to try that again with another expression. This time it's 6x plus 21. And what we're looking for is a common factor. It's not 2 like in the other one. This time it's 3. Because what can we multiply together to get 6? 3 and 2. So we've got 3 times 2 times x. Now if we pull a 3 out of 21, 3 times what gives us 21? 3 times 7. So it's plus is our operation. 3 times 7. We're going to rewrite that. We're going to use the reverse of the distributive property to pull out the 3. And what do we end up with? 3 times the quantity of 2x plus 7. So this expression is equivalent to that one. And we've used the distributive property to pull that out and to show that. And if you don't believe me, we could try substituting in. Let's say we put in 2 for x. So 6 times 2 would be 12. Plus 21, what would that equal? 31, 33. Let's substitute in 3, or what did we substitute in? 2. So we're going to substitute 2 in there. So we've got 3 times 2 times 2, which is 4. That's going to give us 2 times 2 is 4, and 3 times 4 is 12, plus 3 times 7, which is 21. And that's going to equal 33. So if you do the math, that's how you would check to see if your expressions are right, are equivalent. You would just substitute in when x is equal to 2 and x is equal to 2. And that's all we did. See, we just got the 2 for the x right there. And so we had 3 times 2 times 2, which is 4. That gave us 12, but we still had to distribute that 3 to the 7, and that's 21. So we ended up with 12 plus 21, which is 33, which is the same thing we have there. So they are equivalent expressions. I'm going to do a couple more of these for you, and hopefully this is making sense. And if it doesn't, you can replay this video, and hopefully it will make sense. Thanks. Hi, it's Miss Velasco again. Thanks for stopping by. Here's some more problems to work on writing equivalent expressions. Quick review of the distributive property. A times the quantity of B plus C is equal to A times B plus A times C. Works the same way if instead of addition, you had subtraction in that problem. So I have 2 different problems up here we're going to work. The first one is 2 times the quantity of x plus 3. We need to write an equivalent expression for that. And what would that be? Using the distributive property, we're going to distribute the 2 to the x and get 2x. And the 2 times the 3. What's our operation? It's plus. We're not done because you have to finish out the multiplication. So you have 2x plus 6. This expression is the same as that one. They're called equivalent expressions. Pretty simple, huh? I hope you're getting it. Let's do another one. 6 times the quantity of 4x minus 1. That's equal to, use the distributive property. What is 6 times 4? 24. So it's 24x. And what is 6 times 1? 6. 24x minus 6. That expression is equivalent to that one. Thanks for stopping by. I hope this is making sense. All right. It's Miss Velasco again. Here's another problem for writing equivalent expressions. So let's take the expression of 8x plus 2. That already looks pretty simple, right? We're going to use the distributive property and we're going to write an equivalent expression. What common factor can we find in here? What common factor do we have for 8 and for 2? Hint, it's 2. So 2 times 4 is going to give you 8, right? X, and let's add 2 times 1 is going to give you 2. Does that make sense? We broke down the 8. 2 times 4 is 8 times the x plus 2 times 1 gives us 2. So how can we rewrite that to be equivalent? Well, let's take our 2 out here times the quantity of 4x plus 1. What we did, since we factored, we found that 2 is a factor for 2 times 4 to give us 8, and 2 is a factor times 1 to give us 2. So I took out the 2 here, and I took out the 2 there, and I put it in front of the parentheses. And what does that leave me with? 4x plus 1. Does that make sense? Hope so. See you on the inside. Bye. It's Miss Velasco again. We're going to keep going. Equivalent expressions. So here's a question for you right out of the book. Number 5 says, what is an equivalent expression? Do you know? I'll give you a second to think. What is an equivalent expression? Write it down on your paper. And I'll give you a minute, and then I'll tell you what the book says. What is an equivalent expression? Well, the book says that an equivalent expressions are 2 expressions that, when simplified, have the same terms. Let's look at that. When simplified, they have the same terms. The 8x plus 2, they have the same terms. Okay, when simplified, that means when you solve them, when you work them. You wouldn't leave this problem like that because that's not simplified. So 2 times 4x is going to give you 8x. And 2 times 1 is going to give you 2. Do they have the same terms? Yes, 8x plus 2, 8x plus 2. So these are equivalent expressions. That's supposed to be a little star to let you know they're equivalent. All right, see you next time.